record here. So what we went over last time, and I'm just saying it again so it ends up on the recording, the inverse trig functions that are in quadrant 1 and 2 are the even ones, cosine and secant. And the ones in quadrants 1 and 4 are the odd ones, which are all of the others. So what we're going to do today is take that information and actually answer some questions. Just like 2 things before we start. You're doing the exact same thing we've done before, but in reverse. You're just going to go backwards. So instead of being given the pi over whatever and giving your answer as square root of 3 over 2, you're going to be given the sides, like the 1/2 or the square root of 3 over 2 or whatever, and your answer is going to have pi in it. So you're just going backwards. Also, before we start, you might see here, pick one of the 6 trig functions. I don't care. Which one's your favorite? Cotangent. All right. You can see it written as cotangent with a -1 like that, or you might see it written arc cotangent. Those are 2 different forms of notation that mean literally the same thing. Low key, they mean the same thing. Did I use that? Right. Okay. So if you see an arc or you see the little -1, those mean inverse. Okay. I don't know why we have 2 versions of the same notation. I wish that we had just collectively picked one and gone with it. All right. Now, if your side is positive, what quadrant are you going to be in? 1. Good job. If it's negative, it's going to be whatever the other option is, either 2 or 4. So usually I get asked at that point, hey, Miss Cole, so no triangles will be in quadrant 3? Correct. If you draw a triangle in quadrant 3, you've done goofed. All right. It's 1 if it's positive. It's either 2 or 4 if it's negative, whichever, if it's even or odd. Okay. So look at this one. 1/2. That's positive. You're going to draw a triangle in quadrant 1. We're on our way. Now, where does the 1/2 go? Well, this says sine. Sine is the y value. So the 1/2 goes where the y value is. What does that mean this other side needs to be? Square root of 3 over 2. No. Aw. Now here's the $1 million question, your answer to the whole thing. What is the angle that goes across from the 1/2? Well, again, 1/2 is a little one. Yeah, pi over 6. And so that is your answer. So your answer is the thing with the pi in it. Now, this next one is a little tricky. I probably shouldn't have put it as the second question. That is not going to be a triangle. That is going to be your circle. So using a word like up, down, left, or right, sine is the y value. Where is the y value -1? Up, down, left, or right? Yeah, down. Okay, so 0, -1. That's like the quote unquote work that I need to see. Now your answer is the thing with the pi, the amount of rotation. Here is the thing. You cannot rotate all the way forward to that. You don't have these 2 quadrants. Do you remember me saying it's like the bridge is broken and you can't get to the other side? The only way you can get there is to go backwards. So it's negative something. Good, -pi over 2. You went backwards pi over 2. So it's your amount of rotation that is your answer. I threw this one on here to make you think, why is it called a unit circle? It's 1 unit in each direction. Can you go 2 units then? No, that's an unanswerable question. That's like a NA. You can't answer that. No, undefined is an answer. So we want no answer at all. So it's a unit circle. You can only go 1 unit in each direction. You can't get 2 units away. It's like, yeah, I just threw it on there so we could have a conversation about it. That's all. I would never put something like that on a test. It's an unanswerable question. All right, arc cosine of 1. So this again is going to be a circle. Cosine is the x value though. So where up, down, left, right is the x value 1? To the right. Good. 1, 0. So again, that's like the quote unquote work you need to see. Now your answer is the thing with the pi in it. How far did you rotate if you're, yeah, none pi, no pi. No pi for you. I always think of the Seinfeld episode where he's like, no soup for you, but I'm old. So that's, or does anyone know what I'm saying? Okay. All right. Oh, this one's negative. Negative. It's not in quadrant 1. That means it is either 2 or 4. You have to look at which trig function you have. Cosine is even, so it has to be 2. So you're going to draw your triangle in quadrant 2. Yep. It's negative. So it can't be quadrant 1. It has to be whatever the other option is. Cosine is the x value, so your negative square root of 2 over 2 goes here. That means the other side is what? Yeah, positive square root of 2 over 2. And that means this reference angle is pi over 4. Now listen, your answer is not pi over 4 though. It's how much you rotated to get there. So how far did we go to get there? Think about when you fill in your unit circle, what some of the options in quadrant 2 are. Good, 3 pi over 4 is your answer. It's how much you rotated. Now, if you're in quadrant 1, like whatever you get just is your answer. That's where you rotated to. But if you're in a different quadrant, you have to think about it. All right, this one's super tricky. Because when you see that 1, you kind of think of the circle. But it's not going to be a circle. It is going to be a triangle. I'll let you answer. Hold on a second. Let me get it in the right quadrant, though. The 1 is positive, so what quadrant is it going to be? Quadrant 1. Go ahead. Do you want to go ahead and give a guess what it is, or do you think you know? Good. Why are they both somebody else? Why do they both have to be square root of 2 over 2? Go ahead. Anything over itself is 1. That's how you get that. So our angle is pi over 4. And because you're in quadrant 1, your answer just is pi over 4. If you're in quadrant 1, whatever you get just is your answer. You didn't rotate far enough for it to be anything different. All right. Do you see how this one is tangent? And we've got a negative square root of 3. You have to work backwards. It is either going to be, let me show you what your two choices are. It's either going to be square root of 3 over 2 over a half, can't talk, or a half over square root of 3 over 2. If you get stuck, it's one or the other. You got a 50-50 shot. But ignoring the negative for a second, which one of these, option A or option B, do you think? A, do you see how these two cancel? You get square root of 3 over 1, which just is square root of 3. Okay, so I'm going to write that off to the side. Square root of 3 over 2 over a half. I don't know which one's negative. I need to place the triangle in the correct quadrant first, and then I'll figure out where the negative goes. It's not quadrant 1. Where's the other option for tangent? 4. Good. So we're going to draw our triangle in quadrant 4. And tangent is y over x. So your y value is that square root of 3 over 2. Your x value is the 1/2. Then you can see which one gets the negative. So which one is going to be the negative? Yeah, good. But again, that was hard. If you're like, hey, that was tricky, you're right. But you have a 50-50 shot. It's either this or reverse them. You know what I'm saying? Like you have a 50-50 shot of getting it. Now, square root of 3 over 2 is the bigger side. So this is pi over 3, but your answer's not pi over 3. It's how much you rotated to get there, and because you had to go backwards, what is your answer? Perfect, negative pi over 3. Nice job. Now this one we actually can get an answer. And you're like, oh, but that other one had a 2 and we couldn't get an answer. But this one's secant. Secant is the reciprocal of which one? Which trig function is reciprocal? Cosine. Good. So we're going to write it as cosine inverse and then put the reciprocal. So what do you get if you flip -2? It'll still be negative, but 1/2. Good. So just rewrite it so that you've flipped it. Now that can't be quadrant 1 because it's negative. So what's the other option for cosine? Good, 2. See, we're getting it. Triangle in quadrant 2. Good, that's the x value. Cosine's the x value. That means the other side, square root of 3 over 2. And that means your reference angle is pi over what? 3. Good, nice job, guys. Perfect. Answer's not pi over 3, though. Good, perfect. Before I could even ask, it's how far you rotated to get there, and that would be 2 pi over 3. This one is cosecant. What is your reciprocal of cosecant? Which one? Sine. So this is sine inverse. Now hold on, I'm going to talk you through this because I don't want it to be that complicated. Your choices are 1/2, square root of 2/2, or square root of 3/2. Just from looking at this, out of those three options, which one do you think it is if you flip that? Square root of 3/2. Don't overcomplicate it and do all the rationalizing. If there's a square root of 3 in it, it's square root of 3/2. Do you get what I'm saying? If it's 2 and you flip it, it's 1/2. If there's a square root of 2 in it, it's square root of 2/2. You only have so many options. Okay. What quadrant are we in since this is positive? 1. Good. Where would the square root of 3/2 go? Think about what sine means. Good. Sine is the y value, so that's going to go here. Other side is 1/2. Perfect. And what is your angle across from square root of 3/2? That's the bigger one. Yeah, pi/3. And because you're in quadrant 1, your answer just is pi/3. All right, again for this, your choices are square root of 3/2 over 1/2 or 1/2 over square root of 3/2. It's one or the other. You got a 50-50 shot. So which one do you think this is? Option A or option B, we'll call them. It's A. Do you see how if the 2's cancel, you get square root of 3/1? It just is square root of 3. So I just wrote that off to the side. What quadrant are we in since it's positive? 1. Quadrant 1. If it's positive, you're in quadrant 1. Cotangent is x over y. So the square root of 3/2 is your x. 1/2 is your y. And what is your angle across from 1/2? That's the little one. Pi/6. Good. 1/6 of a pi is that little slice. And so your answer is pi/6. If you're in quadrant 1, it just is your answer. You didn't go far enough for it to be anything else. Go ahead. Yes, that is your work. Because there's like so little quote unquote work for these, I do want to see that. And especially the reason I need to see the reference angle is sometimes the reference angle and the answer don't match. So I do need to see them both. Okay. So when you look at these next ones, I'm combining two functions. One is an inverse function and one is not. These are not on the unit circle. Notice there aren't square root of 2/2. Go ahead and close that. Square root of 3/2, like all of that. They're not on the unit circle. So you are back to SOHCAHTOA, opposite, adjacent, hypotenuse. Okay, so we're back to that. First of all, 3/2. Is that positive or negative? Positive. So our triangle is in first quadrant. I feel like that calms you down. You're like, hey, I got started. I drew a triangle. Okay.
Yeah.
So tangent is opposite over, good. See, you remember stuff. So 3 is your opposite, 2 is your adjacent. It's not that hard. And then you're going to do Pythagorean theorem to get the other side. So 2 squared is 4. I'm going to kind of shorten this because I don't have a lot of space. 2 squared is 4 plus 3 squared is 9 equals c squared, x squared, r squared. I don't care. Call it whatever you want. But 4 plus 9 is 13. And so it is square root of 13. Other way. Square root of 13. Yeah, good job. So, and if you need to label this, we don't actually know what that angle is. You can call it theta if you want to. I'm fine with that being blank at that point because we don't know what it is. But if you want to put something in there, you can put theta. Go ahead. I'm about to get to that. That is our work. Now we're going to state the answer. We want to do sine using this triangle. Sine is opposite over hypotenuse. Sine is opposite. I need for the chatter to go down so everyone can hear me. So it'll be 3 over square root of 13. And we're going to rationalize. So 3 square root of 13 over 13 is our answer. These ones will look messier because they're not on the unit circle and you have to do Pythagorean theorem and all that. Let's try the next one. First of all, this is negative. And this is cosine. So it's not in quadrant 1. Where's the other option for cosine? 2. Okay, so draw your triangle in quadrant 2. And then you can kind of calm down because you're like, hey, I started, but please stop talking over me. What I have to say to my Algebra 1 students is if you're talking, you're not listening because you can't do both at the same time. So if you are talking, you're not listening. All right, cosine is adjacent over hypotenuse. Don't do the negative. We'll sort that out later. So 5 is adjacent, 13 is hypotenuse. The 5 gets the negative. By definition, the hypotenuse is never going to be negative. And if you want to call that theta, you can. Or if you want to leave that blank, you can. We don't know what that angle is. Now, this is one of the locker combination ones. So if you remember it, we won't have to do any work. 5 blank 13. 12. Good job. 5, 12, 13. You also have 3, 4, 5. I'm just throwing it out there. Does anyone remember another one? It's 8, 15, 17. 7, 24, 25. Is that what you said? I didn't hear you. Okay, I didn't hear you. All right, now we're going to use this work, our picture, to do tangents. Tangent is opposite over adjacent. So that's 12 over negative 5. Now sorry, go ahead. So yeah, when you have a fraction, the negative can go on the numerator, the denominator, or just sit out front. It really doesn't matter. Now these last ones just have u. That means they're kind of weird something. That means they're gonna look more complicated, but you kind of don't do anything because there's not a number there. I'm gonna do this one first because out of the two, it's the easier one. The first thing you want to do is say that it's u over 1. Because if you're going to do opposite over adjacent or adjacent over hypotenuse, you have to have a fraction. Now, I don't know what u is. It sounds like I don't have grammar at this point. I don't know what u is. So we're going to assume it's positive and just put this in quadrant 1 because you have to put it somewhere. So cosine is what over what? So adjacent over hypotenuse. So adjacent is u, hypotenuse is 1. If you want to call this theta, you can. And we're going to do Pythagorean theorem to get this side. Can I just call it a? Is that okay? Okay. So it's going to be a squared plus u squared equals 1 squared. And we want to get a by itself. So what would you do to get a by itself? Yeah, 1 minus u squared. And then here's where you have to listen to me and trust me, because I always get someone that's like, surely there's another answer. I'm telling you there's not. To get rid of the squared, you will square root. And it is square root of 1 minus u squared. No, you cannot break it apart. No, you cannot cancel out the squared and the square root. I promise you can't. If you want to have a further conversation about that, we can do that one-on-one later. I don't want to confuse half my class. I will be more than happy to answer it for you, but hands off, do nothing, be lazy. Got it? Okay. Now you're going to use that work to do tangent. Tangent is what over what? Bless you. Opposite over adjacent. So it's going to be square root of this stuff over u. You cannot do anything to that either. Please just do nothing. I always get kickback over it, so I'm trying to be really like forceful. Like, why is she harping on? Because people always want to argue with me like I'm wrong or something, and I promise you I'm not. All right, we'll go back to this one. This one's just a little harder than that one, so I saved it for last. All right, put the u over 1 because you have to have something over something. Again, we're just going to assume that it's positive because we have to draw the triangle somewhere. So tangent. Tangent is opposite over adjacent. So u is the opposite, 1 is the adjacent. If you want to call that theta, you can, or just leave it blank. And we're going to do Pythagorean theorem to get the hypotenuse. Can I call it c? Is that okay with everybody? Or you can call it whatever you want. All right, so it's going to be 1 squared plus u squared equals c squared. And you need to get c by itself. It practically is. The only thing you're going to need to do is square root both sides and do nothing. I guess you can do 1 squared is 1, but don't try to split this apart. It is square root of 1 plus u squared. But Miss Cole, can't we? No. Okay, that is your work. Now we're going to do sine of that. Sine is what over what? Good. So it's going to be u over square root of that stuff. And the reason I said this was a little bit of a harder problem is you have to rationalize that, which is not difficult. It just looks really messy. It's going to be u and then what? Square root of that stuff over that stuff. And guess what you can do to that? Nothing.